So today we're going to go over some examples of net ionic equations. So let's start with the reaction between lead to nitrate and potassium iodide. Now, I will tell you this particular reaction does form a precipitate, and you would have to know that ahead of time to be able to do this because you're only memorizing limited solubility rules. So let's take PB. Oh, let's take PB, NO3, 2, and react that with Ki. So this happens to be a double replacement reaction, and so we're going to form PbI2, and then KNO3 is the other product. So simple double replacement reaction. Now, here's the thing. Once you've written the molecular equation, then you kind of want to go through and you want to dissociate everything that is going to be soluble. So that first compound, PbNO3, that has the nitrate ion in it. So it will dissociate into Pb2 plus and NO3 minus 1. And I'm going to ignore the subscript 2 for now because, quite frankly, if nitrate drops out of here, it's not going to really matter. Now the Ki then is a group 1 metal, and we know group 1 metals dissociate. So we're going to have a K plus, and then we're going to have an I minus. So it does not matter what that group 1 metal is with, it'll completely dissociate. On the other side there, then, we have two choices for the precipitate. So either the PbI2 is going to stay together, or the KNO3 is going to stay together. And we know group 1 metals dissociate. So what that leaves us with is the PbI2 then is our precipitate. We will not dissociate it. And then the KNO3, we're going to have a K plus ion forming and an NO3 minus ion forming. So now this just becomes like a simple algebra question, right? Where we just literally just take the ions that are the same on either side and cross them out. So we're going to get rid of the NO3 minus. Whoops, get back over to my pen. We're going to get rid of the NO3 minus, the K plus, because we find those on both sides. And what we're going to be left with here is the formation of the lead iodide precipitate. So Pb plus 2, and now we can balance it. It's 2I minus, and we're going to form PbI2. This is a really cool reaction too, because the precipitate that forms is a really bright yellow solid. So that's going through the process of taking a precipitate reaction and going through all the way down to the net ionic. So that net ionic equation is going to show us what actually happens in the lab.